Hi, we're going to try to study the idea of something called average rate. Average rate. Rate is a kind of a way of describing a slope. Average rate could be translated to average slope. Okay? This is going to lead you towards a calculus idea that's very important about instantaneous rate. My name's David. I hope I'm going to help you find the average rate between f of 1 to f of 3. Let's get the slope of that idea. Here's our function, 16 minus 2x squared. 16 minus 2x squared, because it's a x squared, makes a parabola. The negative is a flip of that parabola, and I have graphed it right here. This is an upside down parabola. F of 1 refers to a dot on a graph. It is also a value that we plug in chug. It is also a value that we plug in chug. So if we were to put in f of 1 into our function, calculate this answer, 1 squared first, then minus 2 here, looks like we're at 14. So the y value is 14. Now I have both an x and a y. And that's the beauty of function notation. This is giving us the idea that we're at an xy location of 1, 14. To get a slope, we need to do the change of y and the change of x. The change of y and the change of x. There's a formula for it that I'm not going to review. I'm more of a visual. I kind of make the importance on the visual. I try to get students, especially heading off towards calculus, to think of the slope as a rise that either goes up or down, and the run you should always keep to the right, since we're going to be reading graphs to the left to right. So you can see that this graph, I can't draw it very straight, but it looks like it drops a long ways. There's the negative rise, and goes over an x value. Goes over x values there. So I need to figure out what the y-coordinate is way down there at f of 3. So what is the y-coordinate at f of 3? Because I can't tell how far I've come down without that. So let's plug in f of 3. Let's get an answer. Be careful of the math again. Be careful of the math. Okay, be sure you square first. Square first. Looks like you're going to get 16 minus 9, or 2 times 9 is 18, so we're down at negative 2. So now I can see that the slope of this equation, I'll use m for slope, okay, is the idea of going from 14 down to negative 2, from 14 down to negative 2. So that is a drop of 16. That length of that line that I drew is 16, and it's coming down. So it's down 16. And then looks like we're going from x is 1. Let's rewrite the xy coordinate that we discovered. So x went from 1 to 3. That is a positive change of 2. Slope is negative 8. We have just found the average rate of this function from f of 1 to f of 3 is negative 8. Let's apply this to a problem real quick. Excuse me, go one more here. Oh, not that one, sorry. Okay, here we go. Here's a problem that you'll see. Find the average rate from negative 2 to 1. The first thing you want to realize by context is they're talking about from x equal negative 2 to x equal 1. You want to get that by the context, and that's the idea that we find an average rate from x to x. This is the idea of we're going to find the average rate from f of negative 2, there's the x-coordinate, to f of 1. They give us the equation. It looks like we have another parabola. I see x squared in there, so I'm thinking it's a parabola. But I don't need to see the graph on this one. I just need to get the xy points. I suggest plotting them. Oh, forgive me, I used f, and this is g. Those are g's right there. Forgive me. Okay, so let's get the equation, the average rate by getting the slope between these points. So if I plug and chug a negative 2 to get the y-coordinate, I'm going to get negative 2 quantity squared there. minus 2, that is 4. Negative times negative, when you square it, is 4. 4 minus 2, so we get the coordinate 2. I now have the xy coordinate of negative 2, 2. G of 1 is plug and chug 1. Chug out the answer. 1 squared is 1. We now have negative 1 as the y coordinate. So now I know I'm going from negative 2 comma 2 to positive 1 comma negative 1. Again, there's formulas out there. Y2 minus y1 over x2 minus x1. You may use them if you like. I get it. I think it's important to have the visual of it. It usually prevents negative issues. So if I just plot negative 2, 2, it's about there. And if I plot, if I plot the 1 comma negative 1, it is about here, 1 comma negative 1. By labeling my axes, I can observe the change of y. The change of y went from positive 2 down to negative 1, so that the average rate now, again, I'll just use m for the slope. The average rate now is changing from 2 to negative 1, that's 3. And then the x changes from negative 2 over to positive 1, okay? And that is a positive 3 movement. 2 to get to 0 and 1 more is the way I always think about it. I'm on a number line. So I've got a slope of 1. The second part of this says, what's the secant line equation? Well, I have a slope, and I got 2 points to choose from. I'm hoping you're thinking point-slope formula. I'll just choose the first one here. So I'll go y minus 2, make sure you grab the y coordinate, okay, is equal to slope 1, which is almost unnecessary, identity rule. X minus a minus 2 is x plus 2. And there's your answer. Remember, keep it in point-slope formula. Just box it and walk away. I hope this helps. Peace.